Hey everyone, what's going on? Today I'm finally going to get around and I'm going to make a tutorial on how to make a lift in Minecraft using Project Red. Almost said Red Power 2. No longer exists. But I will be using Project Red and Computercraft, especially since the computers from Red Power 2 no longer exist. Um, I got this. I wouldn't say I got the idea. I've been nagging the original creator of this series to make the tutorial because ever since he said this,
Yeah, I think so. It's probably
Yeah.
worth discussing what our plans are for this
Oh yeah, good
series,
point.
though.
So what we're looking at doing is building a massive kind of factory come fortress, possibly a hotel with a bar and well, everything really. We want to do all sorts.
Yeah, especially we want to make a lift.
A lift. Yeah. Okay, yeah, we want to try and make a lift.
Nope, we want to make a lift.
Okay. Yeah. Let's go and punch some trees, I think.
I have been fascinated by how he did it, and the response was, I've forgotten how to do it. So I was like, okay, I'm gonna learn how to do it. And here's that video of my final result. Now, before we start, let me preface this by saying this. I hate Lua. I do not like it. I do not like it as a language. It goes against a lot of the things I was taught with coding, such as no semicolons at the end. The way some of the wording is written out, I just don't like it. So, if you see my code getting sloppy, which it is, it's extremely sloppy, please do not comment that you should have done it this way, you should have done it that way. I know I just got the code working after a long and tedious attempt of trying to replicate the code because the original code was written in Forth. So I had to basically rewrite the code from scratch. So please do not leave comments saying this. I know it bugs me as much as it bugs you. Anyway, let's get to this and have a look at this lift, shall we? I think we should. Let me start by saying I am running this on a server because in the single player there seems to be a bug with Computercraft and Project Red that if a computer is connected to a set of frames, occasionally the frames will just straight up disappear, destroying the entire lift. I have no idea why. I think it's a block update to do with Forge Microblocks, but for whatever reason it just disappears. So, but this does not that does not happen on a server. So if you notice any stuttering or lag, it's because I'm playing on a server. Even though Minecraft 1.12.2 runs on an internal server, so I don't see how this fixes it. It just does. Oh, screenshot. I want to press F1. There we go. So, we're on the original map. I managed to pilfer this from the original creators. Me and a friend painstakingly rebuilt this entire map. Because this world was based in 1.2.5 TechIt, a lot of the mods they used no longer exist, so we had to substitute here and there just to build up everything. So if there's slight differences, if you know the original series, which I will link down below because it is a great series and is what taught me basically modded Minecraft. That and the creators' other main series back in the Technic days. There is a difference, so go and watch. But yeah, this is the exact. Me and a friend painstakingly rebuilt this as a 1-to-1 scale with some minor additions just to neaten stuff up. So anyway, let's head into the Tower Hotel, known which they called the Bastion. But before we go, all hail the pork. So we're at the Bastion, and the lift is already on the first floor. So great. We'll talk about this button in a minute. So let's go in here. Let's give a demonstration. Let's open up the computer. It says, please choose a floor. Now let me restart this. There. Please choose a floor. -1, basement. 0 is ground because we're from the UK. First is the first floor. Second, third, fourth, fifth, sixth, seventh. So let's go to the basement because I need to show you the entire workings of this computer system anyway. Go into floor 1. Close the doors, and down we go in a very juddery function. This wire I will talk about later on. This is just to detect what level the lift is currently on. Okay, and we've arrived, and the door's open, so let's jump down. Okay, these signs. This is just for anyone who does manage to get on this server. Please do not touch anything in here, because this is a pain. It looks neat because of all the bundled cable and everything, but it was a nightmare to make. So, this computer here is the main computer. This was a testing computer. I can get rid of that. Okay. So here we have the main computer program. You cannot see this because it is set to start at the startup of the computer. Actually, let me just put the computer back a second. Put a disk in. And if I do /ls, if I list the disk's contents, so if I do edit 1, okay, this program you're about to see is the exact same program that was on the other computer, but because that runs at startup, I do not have the ability to access it. So, as I said at the beginning of the video, please do not judge me. I know this is going to look bad, but it will work. So, let's have a look at it together then, shall we? Ah, that didn't work. So, give me a second. I'm back. I didn't realize that I had 2 brown floppy disks in my hand and put the wrong one in. So, test call, exactly the same as this system here. So, let's edit this test call. Edit. Disk. Test call. Now, I know it looks horrible, but we're just going to roll with it. So I have 3 variables: outside, floor side, and call side. The outside is going to be the output side of the system, in this case the back of the computer. The floor side is where the lift will detect what floor it is currently on. That is on the left-hand side of the computer. And the call side is the input for when the user presses the button outside of each lift. So if I go up here, remember the button I said I talked about earlier? That's these buttons. They go on each and every floor. You press this button, no matter where the lift is, it will come down to you. And all of this is contained in a massive, I think it's like 860 odd lines of code, while true loop. So it will do this while the condition is met, which it will always be met. So it will repeat itself. So let's go line by line. If rs.get bundled input. Now, that means if redstone signal gets a bundled input from the floor side, so the floor side has a bundled cable going in, which can have any of these cables over here. So white, orange, magenta, light blue, yellow, green, pink, grey, and light grey. I'm only stopping there because that's how many I know is currently connected, but you can have all of these as well. So it's going to test to see what it's getting an input. So 1... It counts in binary for each number, so white is 1, orange is 2, magenta is 4. To make it easy, here's a notepad that I currently wrote. So yeah, white is 1, orange 2, magenta 4, 8, 16, 32, 64, 128, and so on. And as you see, I've labelled each floor so you know what number represents. If you know binary, that's easy enough to understand. Basically, it doubles the previous number before it. Okay. So it's going to search to see if it's getting a signal from the floor side, which is the redstone torch. So for example, this torch here is currently connected to the white bundled input cable. So it's currently reading this if statement. Then I have an os.pull event redstone, which means it's going to keep searching until it gets a... it's going to keep searching for a redstone input, such as a button press or a pulse of a redstone signal, which is how the computers at the back of the lift shaft work. I'll go over that later. Then I have a nested if statement inside of this if statement. So if, again, rs, redstone, test bundle input, so it's going to test to see if the button pressed matches the color. In this case, if it matches the color white, it's going to print it's already at the basement because the lift cannot move. It's already at that floor. Below it is just a commented out sleep timer, so it sleep for 10 seconds before it will automatically restart the program ready for the next user input. And that's the same for each floor. So if the lift is at at the ground floor, and the user presses the ground floor button, it will just run this code again. But instead of saying already at basement, it'll say already at ground floor. This print statement here is just for debug purposes. The user will never be able to see this because this is for the computer in the basement. So moving on. The next if statement inside of the first if statement, as I said, this is just a bunch of nested ifs. This is not the way to do it. I could have done functions, but I decided to just go with what I know would work. Because I'd never learned Lua in my life, I do not like it. Give me C# any day of the week. So, if redstone, much the same as the previous one, is going to test to see if it gets an input, and this time it's going to test the input for orange, which is set to go to the ground floor. So it's going to print for this computer a debug of going to ground floor. Then it's going to set a variable with the value of 0. Then it's going to initiate a repeat cycle. So it's going to repeat whatever is in this set of code until it meets its condition, which is at the bottom. So it's going to set the bundled output, as we said, is the back of the computer. And that's set to a bundled cable, hence the bundled output. And it's going to set the color red as active. Then it's going to sleep for a second. Then it's going to set the output to 0. Then it's going to sleep for a second. So these 4 lines of code here is basically creating a redstone pulse for a second. And then it will increment the value of I by 1 until I is equal to 7. So that breaks the repeat cycle. Once I is now equal to 7, it will stop that repeat, and it will be at the ground floor from the basement, because each floor is 7 apart from the floor below, except for the first floor to the ground floor, which is 13, because the ground floor is a lot more grander than the other floors. And that's basically it. It just repeats on and on. So if magenta is pressed, it's going to say go into floor 1. It's going to do the exact same thing. It's going to pulse the red output until it reaches 20. So as I said, 7 from the basement to the ground floor, and then another 13 to the first, so 20, and so on and so forth. So let's find one where you would have to go down. So okay, so you can see here's a new if statement. So if rs.get bundled input again is testing the floor side for 2, so orange. So if it's on the ground floor, it will start the redstone event again, so searching for redstone pulse. If it gets a signal pulse from the color of color of orange, because it's already on that level, it's going to say already at ground floor. And sleep again, run, and then restart the program. And then it's going to test to see if it gets an input of white, which was actually the basement, so it's a floor down. So instead of being I plus 1, it's going to be I minus 1. So I starts at 7 because we know it's 7 blocks above the above the basement. Repeat, same thing, but instead of pulsing the red wire, it will pulse black, and that is set to the motor for going down. Sleep, then you'll turn it off. Sleep again, and then I minus 1 until it reaches 0. So each time it pulses, it will take 1 off 7 until it reaches 0, and then it knows it's at the basement. And that's pretty much it for the entire system all the way through. It's not pretty, as I said, but it works. So yeah, all this code will be in the description in a text file or a paste bin or something of that sort. I don't know why you'd want to modify this code unless you want to clean it up, which would be great, but apart from that, I wouldn't bother. This code is not nice and not efficient. So yeah, 871 lines of just a massive if statement in a while do loop. So now we're going to close that and forget we ever saw that. But that program is on this computer at startup, so you can never interact with that program. So this input here is the floor input, so it's getting the input from the white at the moment, and it goes all the way up the side of the bastion. And then the input to the right of it, which is going underneath these covers, and coming along here and around, and then up, is hooked up to the call button on each floor. That's pretty much it for that. The way the computer works is it takes the user input and pulses the call button or the call color for that input. So, for example, if I was at the going to the ground floor, if I type 0, it will pulse the orange wire as if someone had decided to call it from the ground floor. It's a very cheaty way of doing it, but I couldn't get that program to work nicely in the main loop of the computer down there. So, but as you can see, it does work. And that's pretty much it. However, I do have this laid out horizontally without all of the without all of the with all the decoration, so it's easier to understand. So I will be right back in a couple of seconds with a laid out horizontal view. Alright, so here we are at the top secret. Yeah, I need to change that since I've remade all of this, but yep, the Ricochet Development Center. And down we go. A little bit of server lag, never hurt anybody. So yeah, this visual representation here is, imagine the back of the bastion. This is how it is without all the blocks surrounding it. Here is the call buttons for each floor. And this is just an output to help me tell what floor the lift is currently on. And here's the main computer that we saw in the basement. And this computer is the computer you would see at the back of each floor. And as you can see, it's just wired in line with the input for the call system. And it will pulse the color corresponding. So this computer is waiting for an input. And this computer is waiting for an input. We can see it's currently at the ground floor. Remember I said white is equal to 1, which is equal to floor 0, so that's the basement. So let's send it up to the ground floor. So it's pulsed, that button pulsed orange, which went along and into the system. Realized that orange was pushed. It knows how many to count, and it will go until it reaches its condition. This light here, the black and the red. The black wire is into this lamp to show whenever the down motor is active. The red wire is into this lamp, showing when the up motor is active. I'll give you a overview of the wiring in a second. But as you can see, it's reached its ground floor. There we go. And to show it does exactly the same thing, if I say I want to go down to the basement, pulse is white for a second, just long enough for the system to realize that someone might have pressed the button to go down to the basement. And that's that. And it just goes along for the entire set. So I've put signs up so we know. So we got the basement, ground, first, second, third, fourth, fifth, sixth, and all the way back there is the 7th. So all this is really is a massive bundled cable, but instead of having this flat bundle cable, it would be framed bundle cable inside the bastion to make it easier to hide. That comes along down here. It splits here. This one is the input on the computer to say where the lift is. And as I said, it splits, so we follow the split. So we follow this, and you can see it's outputting that is at the basement level. So this is just a visual representation. If we follow this back one here, this will go up to the motors, so it will pulse red if it needs the motor to go up. It'll pulse black if it needs the lift to go down. And again, it is split off here, going along. And as I said, whenever the black is pulsed to go down, this light will pulse on. And whenever the red is pulsed to go up, this light will pulse on. So again, another visual representation. This is the input for the call system again, as I briefly mentioned a couple of minutes ago. And this code just pulses that. Let's just break this a second. Floor edit. The floor edit does not exist, so it's broke the system. So if I edit the floor choice, this is the code for the pulsing. So io.write, which means it's going to write to the terminal. Please choose a floor -1 through 7. Input is a variable for io.read, so it's going to read the user's input of what they typed and store it in the variable called input. Then it's going to print. Print and io.write do pretty much the same thing. It's hard. I can't really explain it because this is the first time me delving into Lua, so I can't explain the difference. But print is going to print to the terminal, write to the terminal, go into the floor, and then it's going to insert the user's choice from the input. And then it's just a bunch of if statements checking that if the input is equal to -1, so the white is pulsed, it's going to... So yeah, if the user input's -1, it's going to pulse the wire on the right hand side for the color white, sleep, turn it off, sleep, and then it's going to restart the program. So it's literally as if someone has just gone along and pressed the button. And let's set the time to... It's getting dark. Because it's getting dark, there we go. But yeah, it's literally as if someone has just pressed 3. So if someone presses this button 3, it will... It's 3. It will pulse the yellow. Literally the same as if someone had typed 3 in this. And yeah, it's just a repetition of if statements checking. So that's pretty much it. Let's restart this program. Yeah, I can't really explain it any more than that. That is the lift. It's a lot simpler than I thought it was when I first watched Richard Ricochet make this. So yeah, it's a... But then again, he used Forth, which doesn't exist anymore, which is I believe actually a lower level language. So don't quote me to that. Anyway, so thank you so much for watching, and I will catch you all next time. Ta-da!